Hello, we are from Group 3 and we are going to present our assignment. Uh, First of all, our group consists of 5 group members, me, FIRDAUS, AIREEL, ALIF, BISWAJIT and one ADLI. Okay, so first now I'm going to present the first question about the data sorting. Okay, so for weight, we have sort the range here for 10 mg range, and then this is the frequency, and as you can see, this is the bar chart we made, and it looks like bell shape. This is the minimum for the weight is 317 and 82. Maximum value is 393.33. The mean is 349.1543. The median is 348.995. The standard deviation is 13.2328. The variance is 175.107. Let's go for relative density. Sort the range for 2%. And this is the bar chart. The minimum value is 82.8, the maximum is 93.3, the mean is 88.139, the median is 87.9, the standard deviation is 1.922958, the variance is 3.697768.
And for the tensile strength, we sort the range for 0.2. Here is the frequency and here is the bar chart, which is like bell shape. The minimum is 6.6, the maximum is 7.7, the mean is 7.152, median is 7.1, standard deviation is 0.194, and the variance is 0.0376. Lastly, for the shift, this is the frequency and this is the bar chart.
Hi, Assalamualaikum. My name is IZMAN. For part B, first we do the arrangement of the data. Since the weight data in the appendix is random and need to be arranged in an order, so we arrange that in ascending order as shown in the table. Next, for the hypothesis statement, for null hypothesis, the weight of standard tablet produced by manufacturers is normally distributed, while for the alternative hypothesis is otherwise, which is the weight of standard tablet produced by manufacturers is not normally distributed. Next, for tabulation of data, as you can see, we have a table here which contains frequency and probability for each range. We obtain frequency from the given appendix and we obtain the probability using the statistical table for normal distribution. And to make sure that this table is correct, we look at the summation of frequency and probability, which frequency gives total of 200 and probability gives the total is 1. So that means the table is correctly verified. Next, for the test statistics, we obtain the expected value using the formula, which is total frequency times with the probability. For example, for the first expected value, we times 200 with 0.0162 and we get 3.24. And next, for the chi-square value, is actually using formula which is observed value minus with expected value and square them and divide them with expected value. So for the example, for the first chi-square, 2 minus with 3.24 squared and divide with 3.24 and then we get 0.4746. And then we sum it all and we get 3.7647 for the chi-square value. Next, we have to merge the data of expected value below 5, and then for the new expected value, we can see here for the 12th observation data, we get 15.28, and also for the 14 observed data, we get the same 15.28. For the new chi-square test, we get 3.6482. For next step, we obtain critical value from the statistical table. Using the formula, we find the V and we get 7, and for alpha 0.05 and V is 7, we get 14.0671. Next, for decision rule, we will reject hash naught if chi-square test is greater than the critical value. So for this case, since the chi-square test is 3.6482, which is smaller than critical value, which is 14.0671, we do not have enough evidence to reject null hypothesis. So as a conclusion, there is significant evidence that the weight of standard tablet produced by manufacturers is normally distributed.
Assalamualaikum warahmatullahi taala wabarakatuh. My name is MOHAMMAD ADLI and I'm doing part C. Okay, for part C, first I divide the if shift and the if shift for the wake. This one is shift for the morning one, and also the wake for the morning, and this one is for evening, and the value of wake for the shift evening shift, and this one is for night shift and also the wake. Okay, for our solution we use ANOVA with single factor. For this this is the data that I collect it from the previous table. This one is for the morning, this column is for the morning, and the next column is for the evening, and the other one is for the night shift. Okay, for ANOVA we use ANOVA single factor, where we assume alpha is equal to 0.05, and this one is the summary for each group, morning, evening, and night. And we got the count, sum, average, and variance. Okay, for the ANOVA, first one we got for the sum of square for these three group, and this the F is degree of freedom, MS is means of square, and F is Fs, and this one is p value, and the other one is F critical. Okay, if F critical is more than Fs or F, so we accept the actual. And also if p value is more than Fs, so the actual is accepted. So this one is for the ANOVA single factor for alpha is equal to 0.1, and this is the summary for the groups. Each group we got count, sum, average, and variance. Here is the ANOVA table that we got for F critical. If F critical is more than Fs, so the actual is accepted, and if p value is more than alpha, the actual is accepted too. So that's all from me. Thank you.
Thank you. Now I'm going to report about regression statistics. To understand about the relationship between relative density and tensile strength, we use regression statistics. The summary output of regression statistics for multiple R is 0.86, for R square is 0.74. To understand the variance, we use ANOVA method. The degree of freedom for regression is 1, and for residual is 198. For sum of square for regression is 5.56, for residual is 1.93. So for mean square value for regression is 5.56, for residual is 0.0097. To get the value of mean square, we have to divide the SS value by DF value. Now to get the value of F for regression, we have to divide the MS value of regression and by the MS value of residual. Then we get the value of F, which is 567.74. To get the value of significance F, we have to define an alpha. So we choose alpha is 5%. So after calculation, we get the significant F value is 4.6 to the power negative 16, which is very low compared to the value we choose 5%. So we can clearly reject this hypothesis, and we can say that there is a linear relationship between them. So after plotting the value of relative density and tensile strength, we can we get a trending line between we can see a trending line. So we get the equation of this trending line. The equation of trending line is y equals to negative 0.50949869 plus 0.0869251883x. So now we can predict the tensile strength according to the relative density. So when the relative density is 68%, so we can predict the tensile strength will be 5.4 megapascal. When the relative density is 74.3%, the tensile strength will be 5.94 megapascal. So when the relative density is 80.1%, the tensile strength will be 6.4. Now